is Kenny Randall. He is a master's student at the University of Idaho. He completed a bachelor's degree at the University of Idaho in fishery resources. And during that time, did some work as a range tech and a student biologist trainee for the Bureau of Land Management. And it sparked his interest in livestock and cattle grazing, sage-grouse interactions there. And so he has focused, his master's research is focused on evaluating how changes in timing and intensity of grazing influence plant communities preferred by sage-grouse. And so we're going to go ahead and turn the time over to Kenny and look forward to hearing from him about his research.
So how's that looking on everybody's screen here?
Looks good.
Awesome. Yeah, so thank you for the introduction. My name is Kenny Randall, and I'm a master's student here at the University of Idaho. For me, topics like livestock grazing and wildlife habitat have always interested me. I enjoy thinking of ways that we can use livestock grazing as management tools to help reach our land management and wildlife habitat objectives. With this in mind, I'd like to thank all of you for taking the time to attend my presentation on riparian grazing management strategies in sage-grouse habitat. So to start off, I'd like to provide an outline for this presentation. I'm going to begin by introducing some topics like livestock grazing, the greater sage-grouse, and riparian meadows. I'll then talk about some of the documented effects of livestock grazing on riparian habitats before diving into my research at the Rinker Rock Creek Ranch, which focuses on how different types of grazing influence riparian meadows and sage-grouse habitat. I'll then wrap up this presentation by talking about how to use livestock grazing as a management tool to help enhance your overall quality within your riparian meadows. So let's start off on a topic we're all familiar with here, livestock grazing. As you're probably aware, livestock grazing is one of the most widespread agricultural practices in the world. In the Western United States, it is estimated that livestock grazing influences about 70% of the total land area. Although we know that livestock grazing takes up a large chunk of the landscape, we also know that livestock prefer certain areas of their pastures more than others. For instance, we often turn up cows in areas with water, quality vegetation, or gentler topography. Because of its widespread practice and the tendency of livestock use to use certain portions of their pastures more than others, livestock grazing receives a lot of attention from people interested in knowing how grazing shapes pastures and habitats. To help provide information on the effects of grazing, research is conducted to help answer questions like how does livestock grazing influence wildlife or wildlife habitats, and how does livestock grazing influence plants and soils within their pastures. However, in rangeland settings like southern Idaho, much of the attention on livestock grazing comes from its overlap with an Idaho species of greatest conservation need, the greater sage-grouse. So let's talk about the greater sage-grouse. This is one of the most iconic members of the sagebrush community. It shares a family with pheasants and other grouse species. These birds are relatively large. For reference, males typically weigh between 4 and 5 pounds, and hens can weigh up to 2 to 3 pounds. The most widely recognized behavior or habit of the greater sage-grouse is the performance of males during the lekking period. Males put on elaborate performances by ruffling their feathers, making strange noises, and inflating the large air sacs on their chest, as you can see here on this male, all in the hopes of attracting a mate. Lastly, of course, the greater sage-grouse can be found in sagebrush steppe habitats, meaning that it exists in the Western United States and regions of southern Canada. So let's talk food, since we just came out of lunch. Unsurprisingly, sage-grouse commonly eat sagebrush. However, there are certain times of the year when sagebrush does not cut it in terms of sage-grouse nutrition, so they'll rely on other foods. For example, Insects make up a really important piece of both chick and juvenile sage-grouse diets, especially when they're in early development stages. Studies have found insects, including beetles, grasshoppers, and ants, in the crops of juvenile sage-grouse. Insects are high in protein, which is important for those development stages and these young chicks during these periods of time. The last important piece of sage-grouse diets are flowering plant species called forbs. Forbs are a critical component of sage-grouse diets and an important piece of today's presentation. So I'm going to take a minute to explain which forbs are more important to sage-grouse and how you can recognize these forbs on the landscape. So for some reference, forbs are any flowering non-grass species. So there are a lot of them, but certain forbs are more important for greater sage-grouse than others. These are called preferred forbs. Preferred forbs have properties that benefit sage-grouse, like high protein content, or characteristics that attract insects high in protein that can be fed on by sage-grouse. The protein in these forbs is particularly important for sage-grouse hens preparing for egg laying and nesting, and those juveniles and chicks during development stages. So sage-grouse preferred forbs are not rare or uncommon on the landscape, and some prime examples include dandelions, alfalfa, clovers, or gilias. Dandelions are high in protein. Alfalfa and clovers provide excellent forage for most of their consumers, and gilia is great at attracting insects that are fed on by sage-grouse. Now that we know a little bit more about them, if you're interested in building your knowledge on forbs important to greater sage-grouse, the technical reference, Common Native Forbs of the Northern Great Basin, important for greater sage-grouse, is an excellent starting point. So all that aside, the biology and the diets of sage-grouse are interesting, but it's not what drives their importance to range and land management. Instead, large population declines and habitat loss have put sage-grouse in a difficult position. Since the mid-1960s, sage-grouse have experienced population declines of almost 66% range-wide. This decline is coupled with a range contraction of roughly 56% since the mid-1800s, meaning that sage-grouse habitat has shrunk to less than half of its original size in just the last 200 years. Mechanisms driving habitat contractions include habitat conversion or degradation and alteration in fire frequencies. These rapid population declines and range contractions emphasize the need for intervention and management of remaining habitats, which is vital to the future of the species. One well-documented factor to sage-grouse success is the survival of sage-grouse chicks and juveniles during development stages. With this in mind, by understanding the seasonal movements of greater sage-grouse throughout portions of the landscape, we can identify areas that are most important to conservation to help improve sage-grouse success. So let's talk about the year from a sage-grouse perspective. In the spring, males and females meet at those lekking sites where males conduct the flamboyant displays I talked about earlier in the hopes of attracting a female. Females will select their mates, be bred, and then return to sagebrush so that way they can nest and incubate eggs. The incubation cycle lasts about 25 to 30 days, after which the chicks hatch, and the grouping of chicks is called a brood. Sage-grouse hens and their broods will then move through sagebrush in search of food resources, high in those crude protein contents important to the developing youngsters. During the summer months, as we all know, it gets pretty hot in rangelands. An upland condition can get really difficult, which is why sage-grouse begin their movements towards riparian areas, or areas with more water. Because of the increased water availability in riparian areas, preferred forbs, like those ones fed upon by sage-grouse, are able to persist longer through the summer, which means sage-grouse and their broods hang out around these areas through much of the summer and early fall. In the fall, as the temperatures begin to cool, sage-grouse will follow these riparian corridors to higher elevations. At the same time, they stop relying as heavily on insects in preferred forbs and start relying more on sagebrush. This is preparing them for the rough winter months ahead. When the snow falls, it pushes sage-grouse back to lower elevations. At lower elevations, sage-grouse rely almost entirely on sagebrush throughout the winter for food and for shelter from the elements. With this timeline and what we know about the importance of sage-grouse chicks and juveniles' survival to greater sage-grouse populations, we can identify the importance of riparian habitats during the summer months to sage-grouse populations. So let's talk more in depth about the riparian area itself. A riparian area is any portion of the landscape with increased water availability. In general, surface and subsurface water flow patterns are directed to these areas by variation in adjacent topography. They're really important in rangelands because water leads to greater amount of forages, especially compared to the uplands. Plants like sage-grouse preferred forbs are able to grow longer in the summer because of that water availability, as we discussed, which makes these places critically important for management when it comes to a sage-grouse perspective. We also discussed that livestock tend to hang out in areas with gentler topography, quality forage, and water. Well, these are all characteristics of riparian areas, meaning that livestock tend to hang out in these areas when given the opportunity. But outside the scope of both sage-grouse and livestock, these riparian areas are important to a large number, estimates of 70 to 80% of both plants and animals in rangelands. This is great, except for the fact that in the Western United States, riparian areas make up a very small proportion of the landscape, with estimates below 3% of total land area. To ensure that riparian meadows can continue to provide valuable resources for livestock production, we need to figure out how to use livestock grazing as a management tool to provide for the other 70 to 80% of plants and animals that rely on these areas. So next we'll talk about documented effects of livestock grazing and how they influence riparian meadows important to greater sage-grouse. So before I fill in this chart, I want to describe what's going on. We have positive and negative effects on the left side of this screen and direct and indirect effects across the top. Positive and negative are pretty intuitive, but direct and indirect may be less intuitive. So the effects of livestock grazing on sage-grouse habitats in riparian areas come in that direct and indirect form. A direct effect occurs when livestock grazing directly influences the quality of habitat for greater sage-grouse. An indirect effect occurs when livestock grazing influences a component of the riparian area that in turn serves as either a benefit or a detriment to sage-grouse habitat. I'll provide some examples for clarity. An example of a direct positive effect of livestock grazing in riparian habitats is that cattle grazing has been documented to stimulate the growth of sage-grouse preferred forbs. This is a direct benefit because by stimulation of these forbs, there are more resources and the quality of sage-grouse habitat in these riparian areas improves. An indirect positive effect of livestock grazing is that it can create gaps in dense vegetation canopies, which then allow for preferred forbs of sage-grouse to grow and establish. Without grazing, and without those gaps being created, there could be less sage-grouse food resources available within these meadows. A direct negative effect of livestock grazing is that overgrazing can interrupt the hydrology of a riparian meadow. When I'm talking about hydrology, I'm talking about moisture. So if we reduce or influence the moisture levels within these riparian areas, we are consequently limiting the amount or extent of that riparian area, which is a direct reduction in sage-grouse habitat. Lastly, an indirect negative effect of livestock grazing in these riparian areas is that livestock grazing can promote or increase the number of invasive plant species. And invasive plant species can crowd out or make it more difficult for sage-grouse food resources to grow and establish. So next, I want to talk about my research at the Rinker Rock Creek Ranch in South Central Idaho, and how this research is helping determine the best grazing management strategies in riparian meadows. So the Rinker Rock Creek Ranch is a research station operated by the University of Idaho in Blaine County. The ranch has a nice mix of both upland and riparian habitats, which provide an ideal setting for riparian grazing research. Our work at the Rinker Rock Creek focuses on the responses of two riparian meadow habitat characteristics to livestock grazing. First, we are interested in how livestock grazing influences soil moisture. As a key component of riparian areas, it is important to determine if different grazing management strategies influence soil moisture characteristics differently. We also know that the importance of water when it comes to forage production in these areas and the production of sage-grouse preferred forbs during those summer months. Which brings me to the next question. How does livestock grazing affect sage-grouse preferred forbs in these riparian areas? As a critical resource to developing sage-grouse broods, understanding how grazing influences the numbers of preferred forbs in riparian meadows is crucial to determining the best grazing strategies for sage-grouse habitat. And our final question stems from our interest in the application of this research. Within different grazing management strategies, where do we see the best gains of livestock? This question is important to me because I'm interested in maintaining the profitability of livestock operations, especially those that can graze in a manner that sustains or enhances riparian habitats for all wildlife species, including sage-grouse. Before diving into this research, though, I do want to point out one caveat. This is Meadow Foxtail, Alopecuris pratensis. For those unfamiliar with Meadow Foxtail, this is a really dominant and competitive cool season perennial bunch grass. It has a broad climatic adaptation for both drought and water saturated conditions and establishes quickly, creates a dense vegetation canopy, and can easily outcompete other plant species, including sage-grouse preferred forbs. The reason that I want to note the presence of Meadow Foxtail in our riparian grazing strategies is because it's important to know how our pastures looked before we began grazing. We started with a relatively low diversity of plants within our pastures, which is not ideal when it comes to pasture management because plant diversity plays an important role in pasture health, from soil biota to pollinator communities. With this in mind, our grazing treatments were made to promote the growth of less competitive forb species, important to sage-grouse, under difficult starting conditions within these pastures. So now that we have the scene set, let's talk about the actual grazing strategies that we employed. So we built pastures for short duration grazing treatments where grazing took place for about 16 days. Because these treatments were applied over a short time span, we sampled soil moisture and sage-grouse preferred forbs in these pastures before and after grazing. We also sampled these pastures in September to assess riparian habitat characteristics after a period of regrowth. We also tracked changes in riparian meadow habitat variables in our continuous grazing pastures. Continuous grazing pastures were those grazed by livestock for about 3 months throughout the summer. And this represents a more traditional management type for riparian areas in this portion of Idaho. Continuous grazing pastures were sampled before grazing began at about the beginning of July, and with the short duration grazing pastures in the end of September. Lastly, we built 3 pastures that were not stocked by cattle to serve as controls. The figure on the right here shows our short duration grazing pasture establishment in the best meadow portion of the Rinker Rock Creek Ranch. So there's some more complexity built into our short duration grazing trials. And that is that we have manipulations of both timing and intensity of grazing taking place. We grazed pastures in the beginning of June, which we classified as an early season graze, and at the beginning of August, which we classified as a late season graze, for 16 days. We grazed at different times because we were interested to know if grazing earlier or later in the season provides better opportunity to establish sage-grouse preferred forbs and retain soil moisture within pastures. During both early and late season grazing trials, we also changed the stocking rates of heifers to achieve different levels of utilization. Control pastures provided riparian areas with no utilization. Moderate intensity pastures were stocked to achieve about a 30 to 40% relative use. And high intensity grazing pastures were stocked heavier to achieve a 70 to 80% relative use rate. These differences in timing and intensity were created to see which grazing strategy promotes the best riparian habitat quality and which grazing treatments provide the best daily gains for heifers used within our short duration grazing trials. So let's talk about some of our results. This chart here shows the difference in soil moisture within all of our treatments across our sampling period. Hopefully you guys can see the laser pointer here. So each box here depicts a different grazing treatment that was applied. For clarity, here at the bottom, our early season grazing took place in June. So these first two measurements are the before and after short duration grazing in June periods. This is followed by our late season grazing in August. We had pre and post late season sampling in those periods as well. Lastly was the regrowth period, and this was a cumulative sampling period where we sampled all pastures at the end of September. So as you can see in terms of soil moisture, in basically all of our pastures, we're seeing decreases across time. This of course makes sense because as we progress through the summer, temperatures are going to rise and there's going to be low soil moisture at the end of the summer when compared to the beginning. One other important thing to note here is the difference between years. So our solid lines here represent the year 2019, whereas the broken lines represent soil moisture samples collected during 2020. As you can see, this solid line is almost always above the broken line in all of our treatments. This tells us that 2020 was quite a bit drier than 2019 when it comes to our soil moisture measurements. So before going on and talking about sage-grouse preferred forb resources, I want to give you some insight into the next slide. So our results on these resources come from the number of forbs intercepted within our pastures. Specifically here, we're looking at Milky Sap Asters, which is a subset of that sage-grouse preferred forb group, which was common at our pastures at Rinker Rock Creek. So Milky Sap Asters, or milky composites, are an important group of forbs for greater sage-grouse. They are recognized by the milky sap when you break their stems, as seen here. And they have high protein contents, important to developing juveniles, have been shown to respond well to grazing, have quick recruitment times, so it's possible to see changes even under short duration conditions, and are listed as a group of high importance for greater sage-grouse. Again, this subset of sage-grouse preferred forbs are not rare or uncommon, and some well-known examples include dandelions, prickly lettuce, and yellow salsify. I want to quickly introduce you to this group of forbs because the next slide will highlight our results on the responses of this sage-grouse food group to our different grazing management treatments. So plotted here are the changes in the number of milky composite forbs observed within our pastures. At the bottom of the screen, we can see those same sampling periods, early corresponding again to June and late corresponding to August, regrowth September. The number of milky composites observed in our pastures ranged from 0 to 8 on average, except for in our continuous pastures, which range from 0 to 15. Each box again is a different treatment, and as we can see, sage-grouse preferred forbs tend to decline in most of our treatments throughout the summer. The one exception to this rule is early season high intensity grazing. This plot here. We do see that decrease between our pre and our post grazing sampling, which makes sense as livestock are grazing in our meadows, but we then see a strange pattern occurring between that end of grazing and the regrowth sampling period, and that those numbers tend to increase again just a little bit. Another important thing to note about this plot is the difference in early season high between 2019, again the dark solid line, and 2020, the broken line. Here we see that 2020 measurements of milky composite forbs were almost always higher during 2020 than 2019. And again, this is under difficult growing conditions because everything was much drier in 2020. This trend is not observed in the other pastures. which suggests to me that early season grazing at a high intensity could benefit the occurrence of sage-grouse preferred forbs within our meadows. So now that we've talked about both soil moisture and forb patterns within these meadows, I want to provide a visual of what pasture conditions looked like. So these pictures were all taken on the same day, August 17th of 2019. As you can see, the conditions of our pastures look incredibly different based on our grazing treatments. At the same time, early season grazing treatments have been out for about 6 or 7 weeks. So we haven't had cows on these pastures for quite a while in these really bright, vibrant green pastures. When it comes to our late season, this time frame corresponds to the end of late season grazing. So these pastures pretty much just got done with their late season grazing application, and this is what they look like. Our season-long grazing in terms of a continuous pasture, so started around July 1st and ran typically through about the middle or end of September, looks all right here. It's not as green or vibrant as some of these other pastures that we see during the early season, but there is some green still within this continuous treatment. Lastly, our control pastures. A little green here, but a lot of herbaceous biomass and a lot of litter accumulated within these samples. Again, remember that 2019 had a lot more moisture compared to 2020, which is the plot I'm going to show you next. So these are pictures from the same pastures in 2020. So these were all taken on August 12th. And again, we have our early season pastures, those grazed in June, late season, those grazed in August, and our entire season, continuous running from about the beginning of July to September, and control not being grazed. So the first big difference here is the lack of green within all of these photographs. And that's likely due to our low moisture levels in 2020, especially compared to 2019. However, there is some green still in these early season grazing treatments. And if you look closely here in this high intensity treatment, this is a forb, which is a clover, which does qualify as a sage-grouse preferred forb that we happen to encounter within these plots. So lastly, here's presented the average daily gains of our heifers in pounds per day in our short duration grazing treatments. Here at the bottom represents the different grazing treatments we tested. Again, early season, those pastures grazed at the beginning of June. Late season, those pastures grazed in August. The circles here represent measurements on average daily gains from 2019, whereas the triangles represent average daily gains during 2020. So the first thing that you can definitely see here is that early season grazing at a moderate intensity, these two plots over here, had the best daily gains. In 2019, they were just shy of about 2.5 pounds, whereas in 2020, our gains were just shy of 2 pounds per day. Our high intensity didn't vary a whole lot between 2019 and 2020, and we're sitting right around 1.5 pounds a day. Our late season grazing did vary significantly between 2019 and 2020. In 2019, our gains were both just above 1.5 pounds in our late season high and late season moderate intensity grazing treatments. However, when we look at those gains plotted for 2020, remember the drier year, we have significant declines, below 1.5 pounds in our moderate intensity and below 1 pound within our high intensity late season grazing. To me, this really suggests that from a producer perspective, it's not in your best interest to be grazing late in these riparian meadows, especially on dry years, in terms of pounds per day production for your livestock. So we will now talk about the management applications of this research. Based on our experiment at Rinker Rock Creek Ranch, early season grazing is important for providing both sage-grouse preferred forbs and weight gains in livestock. In general, soil moisture decreased within all of our pastures throughout the sampling period. And 2020 was recognized as a much drier year than 2019. In terms of forbs, it may not have seemed like much, but we saw increases in the number of sage-grouse preferred forbs in early season high intensity grazing treatments from post to regrowth periods and between 2019 and 2020. This again tells me that early season high intensity grazing was able to help promote the growth of these preferred forbs, even under those difficult pasture starting conditions, competing with meadow foxtail. Lastly, more consistent gains were observed in our livestock during the early season grazing than the late season grazing. And early season moderate intensity grazing produced the best overall gains of any of our short duration grazing treatments. With that in mind, I'd like to outline some steps that you could take to approach riparian grazing meadows. First, assess the meadow. If you see lots of plant diversity in forbs, you're probably doing something right already in terms of grazing management. If you don't see a lot of forbs or diversity, think about ways you could improve it using livestock grazing. As the operator, you have the ability to change the timing, intensity, or duration of your grazing. If you're competing with dominant grasses like meadow foxtail, like we were at Rinker Rock Creek, it might be important that you graze at an early season and high intensity, so that way you can promote the growth of those less competitive plants. We found that this works best, especially in those treatments at Rinker Rock Creek Ranch. Alternatively, we did not see much support for grazing in the late season at either moderate or high intensities from a sage-grouse preferred forb perspective. I would also like to add that late season grazing resulted in poor gains for our livestock, especially during that dry year. As you are well aware, changes may take time and to become more noticeable. Don't expect anything to happen overnight. We saw slight increases in the number of sage-grouse preferred forbs within our early season high intensity grazing treatments, but this was over a 2-year time period. So do not expect anything to change instantly. However, if you apply a grazing strategy and are not seeing the changes you hope for, you should feel free to make adjustments so that way you can help reach your management objectives. Lastly, help is always available. Through extensions like the University of Idaho extension, you have access to some really talented and knowledgeable folks who are interested in helping you manage your riparian pastures so that way they can be the best they can be for all habitat and wildlife and livestock grazing needs. With that in mind, I'd like to thank everybody who's helped contribute to my research project. And I'd like to provide some contact information for those interested more in this research, or if you have questions at a later time that you can't think of today. Attached is my email and the email of my advisor, Dr. Melinda Ellison. Thank you.
Well, thank you, Kenny. I appreciate that. That's some great information. I'm curious your thoughts about long term, I guess, is maybe the question. So in a situation with the meadow foxtail, how many you think is that something in your opinion that is, you know, a long-term thing, as in you're going to have to apply that same maybe early season strategy year after year in order to promote those forbs, or is that something that you think that within, say, I mean, I know it's always difficult to tell especially in a rangeland setting, but is that something that maybe, you know, 3 to 5 years and that's kind of in check and you can do something different? Just curious your thoughts there.
Yeah, so that's an awesome question. And trying to determine the long-term outlook for a lot of these riparian areas can definitely be difficult. One thing, especially if you're competing with really well-established grasses like meadow foxtail, you're going to have to make a dent early in the growing season, and you're probably going to have to follow up on that. As far as long-term outlook, that's really going to be dependent on some of your growing conditions that you encounter throughout those seasons. If you've got really optimal growing conditions multiple years back to back, you're probably going to have to work a little bit harder to keep that meadow foxtail cut down to increase that abundance of preferred forbs. But that's why it's definitely important to track changes. Make sure that you have an idea of where your pastures are starting and where they're going, so that way you can manage, so that way you can reach that sort of objective.
Sure. And we had a question come in. Is it possible to plant forbs that might compete with Meadow Foxtail?
Yeah, so that is another awesome question. In terms of Forbs, you can apply seed mixes to try and increase the number of plants that are preferred by sage-grouse within your pastures. As far as actual competition with Meadow Foxtail or other dominant grass species, it's still probably going to come down to what sort of microsite habitat characteristics you can make for those seedlings. The literature suggests that you need to get in there and punch holes in this dense vegetation canopy, so that way your forbs can grow and establish. So I think that incorporating a seeding component to this riparian grazing management could produce some really awesome results.
And I do see that Dr. Hall commented that that's a project that's currently underway at Rock Creek Ranch with Tim Prather and others looking at ways to establish some desirables there. So one other question I have is related, I guess, to what's the specific window of time where sage-grouse are most likely to use riparian areas? And I'm thinking kind of to where things are drying up and towards the August time frame. Are they just mainly focused in the riparian areas in the early spring, early summertime, or is it a little bigger window than that?
So yeah, they'll start moving to riparian areas as soon as forbs start drying out in the uplands. So a lot of times this is kind of your later spring time period. Calendar wise, you're kind of looking at that June, July, August timeframe. At Brinker Rock Creek, we really saw lots of birds within our pastures towards that end of July and into August timeframe.
Okay, awesome. Well, thank you. You're doing some great research there, and I think there's a lot that we can learn as we try to manage things better all the time. So we appreciate it and look forward to more good and better stuff. So, but thank you.
Thank you.
All right, I'm going to go ahead and introduce our next speakers. We're going to